Okay, so welcome to SAS Viya Transition Topics Office Hours. The two links that are shared here to access previous resources and then the news and events, Laura is going to be sharing those links out here in a couple of minutes to make sure that everyone's receiving them. So before we kick things off and hand things over to Colton, let's go over just a couple administrative announcements. Please remember to stay muted to minimize interruptions during our presentation today. Please use the Zoom chat feature to ask questions related to our office hours topic. Team members will be answering questions using the Zoom chat feature and verbally throughout our session today. Answers for all topic related questions received throughout our office hours will be posted after the meeting concludes. And then any questions that we may not have gotten to, we'll make sure, or we need more clarification for, we'll make sure to be answering those and get those answers out as well. And then all meeting materials will be made available in our CCSQ DNA portal after the event. It just takes us a little bit of time to make sure everything is 508'd and accessible to everyone and track down any of those answers that are still outlined. So with that, today's topic is working with data frames using R, and I'm going to pass things over to Colton at this point. And then Colton, did you want me to drop screen sharing?
You're both on mute.
That's still on.
Okay, I'm going to stop sharing. I didn't realize I was off mute. And Colton, I'm going to pass things over to you now.
Can you see the notebook?
Yep.
Okay. Okay. This presentation and notebook are designed to help master working with data frames in R with a focus on using Spark R. Kind of the key goals today are to provide a searchable Spark data frame using R resource, including a cheat sheet in Spark R, using Spark R and Sparkly R, and I'll show you that at the very end there. Kind of the way you'll be able to search this notebook is clicking over here on this table of contents, and then you can kind of go in and see what you're looking for. If you're looking for importing or exporting data or a common transformation or a QA check, you can go in here and search like that. Another goal that we're trying to get across today is show different Spark R code examples that can be duplicated. We will be using the publicly available data, the Ames housing data set from Kaggle, and I went ahead and uploaded a couple CSV that were on Kaggle, and I uploaded them to the CDR. Here's kind of the main table we're going to be working with, the house underscore price train. We're going to be working with that table primarily, but there are a couple more as well. And then we want to give an overview of each type of data frame: Spark R, Sparkly R, including the advantages and limitations in terms of performance and scalability and use cases. We'll go ahead and demonstrate how to convert data frames between local R, Spark R, and Sparkly R. And then this is kind of our big goal, is to help the user build a foundation using R, and we'll go ahead and focus on three key areas there: reading and writing from the CDR and S3, performing common transformations, and conducting QA checks. Kind of by mastering these foundational skills, you'll be well equipped to handle the large data sets efficiently. This kind of leads right into the key question for the session today: why do I need to learn this? And it's pretty simple. Understanding Spark data frames using R is crucial because it's going to offer that greater scalability and speed for handling large data compared to the traditional R or SAS. So in my opinion, this is certainly worth learning. So let's go ahead and dive in. and get started. So there are three common R data frames offered in Databricks. We got Spark R, Sparkly R, and then the local R data dot frame. Let's start off with Spark R here. It's going to be the official data frame API for utilizing R with Apache Spark. It's a distributed data structure optimized for large scale data processing. It operates across a distributed cluster, leveraging that driver node to coordinate the task, and then the worker nodes to execute those tasks in parallel. It uses lazy execution, which delays the execution of the transformations until an action like count, collect, or display is called. This allows for the optimization of the execution plan. Spark R data frames can read and write directly from the CDR database tables, as well as the distributed storage, such as the Databricks file system or S3. And then this is going to be the kind of the fastest of the three data frames here, due to Spark's distributed computing power. The data object for Spark R is going to be the Spark data frame, and it's important to know the data object type or class, as it will determine what functions can be applied to it. So for example, the Spark R functions can be applied to the Spark R, or the Spark R functions can be applied to the Spark data frame, but not to the data dot frame. So moving on to Sparkly R. Sparkly R is an extension of the Spark data frames family, and it integrates closely with Tidyverse, offering a similar programming style and enabling users to apply dplyr functions such as select, filter, mutate, summarize, etc., directly to Spark data frames. Like I said, it is a Spark data frame, so it's going to be that distributed data structure operating across that distributed cluster, leveraging that driver node with the worker nodes, using that lazy execution. It can also read and write directly from the CDR or S3. One thing that is different using Sparkly R compared to Spark R is you're going to have to create a connection to the Spark cluster, and I'll show you how to do that later. And you create that connection after you load the Sparkly R package. It does leverage Spark. However, it introduces some overhead due to the additional abstraction layer that translates the R commands into Spark operations, making it slightly slower than the more direct interface provided by Spark R. And the data objects for Sparkly R is going to be this table Spark here. Moving on to the R, the data dot frame. It's going to be a non-distributed in-memory data structure for data analysis and manipulation in R. It's going to operate across a single driver node. It's going to use an eager execution, which executes the operations immediately as they're called. It cannot directly read from or write to the CDR database tables or distributed storage. Instead, you'll move the data to that storage, or data must be read into memory after being moved to the local storage or written back to local storage and then moved. It's going to be the slowest for the large scale data processing due to the single node and memory processing limitations there. So with all that being said, we're going to kind of push Spark R today later on. It's going to be kind of the official, or it is the official data frame API, and it should be the fastest. So that's kind of what we're going to show most of the examples in the demonstration today for. But we will also, the Sparkly R stuff will also be included in the cheat sheet. So like I said, all the Spark stuff still applies. The distributed data, the eager execution, the lazy execution, and Spark's execution plan, that all still applies to this stuff. But we're not going to go too in deep, or we're not going to go in depth with that stuff today. If you want to learn more or kind of refresh on some of those topics, you can check out topic 3, Spark data frames, distributed data and processing, and topic 5, working with data frames using Python, where I also talked about the eager execution, the lazy execution, and Spark's execution plan in that topic. Okay, let's hop in, start talking about some data related stuff. First, we're going to talk about converting data frames. And this first example here is we're going to be converting from local R data frames to the Spark data frames. So I go ahead and make a sample R data.frame there. And to convert that R data frame to a Spark R data frame, all we have to do is read in that the Spark R package, and then call the as.data frame function there. To convert the R data frame to a sparkly R data frame, we call the sparkly R library. Like I said before, you're going to have to create a connection, a Spark cluster connection for sparkly R. So that's what this line will do. And then we'll go ahead, use that Spark connection here, and then we'll call the local R data frame there, and then that copy to function is going to go ahead and convert that to a sparkly R data frame there. We can take a look at the structure of the data using the str function, and this will go ahead and show us also the kind of the data object type here. So if you run the structure function on the local R data frame, you will see that it is data.frame. And if you and if you run the structure on a Spark R data frame, you'll see the data object Spark data frame. So that these are going to be kind of ways to keep you on track to knowing kind of what data frame I'm using. And for the last one there, the sparkly R data frame, you can find the data object by scrolling to the bottom here and seeing the table underscore Spark. There's a lot of what I found is the sparkly R output is a little messier than say the local data frame or the Spark R data frame. Moving on to converting from Spark data frames. So Spark R and Sparkly R can't be directly converted from one another. The way you would go about converting those is you would convert it back to a local data frame or output it to a Spark SQL table or output it to an S3 location. So how you'd go about converting from the Spark R data frame to that local R data frame, you just simply use the as.data frame function, calling that Spark data frame here, and that'll convert that into that local R data frame. And then if you want to go from that data frame to that sparkly R data frame, you would go back up here and create that connection, and then specify your local there, and then that would convert the local R data frame to that sparkly R data frame. So if you're going from that sparkly R data frame to the Spark R data frame, you'll go ahead and convert to that local R or that local R data dot frame, and that'll get the you'll go from the sparkly R data frame to the local R data dot frame using the collect function, and then you could use a similar process as I just showed. For Sparkly R, Spark R, Spark SQL, and PySpark data frames are not interchangeable. But you can use so say you want to use R for one process, one piece of your notebook, and then you want to go ahead and call it with Python, or you want to use R for one part of your process and Python for your next. You could do that. You would just have to go ahead and output that Spark, or output that data frame to a Spark SQL table, or an S3 location. And here's an example of outputting a Spark R data frame to a temp table here. And then for this, you would go ahead, say you want to use Python, you would just specify Python in the next cell there, read Spark dot table, and then read in that temp view there into your PySpark data frame. So that's how you'd kind of be able to move between that Spark R data frame and then the PySpark data frame. And you could also do a similar thing using the Sparkly R data frame, saving that Sparkly R or writing that Sparkly R data frame to a table, and then you could go ahead and load it into a PySpark data frame using a similar method as right here. I'm going to go ahead and stop for questions. Do we have any questions?
We just got one in. Does changing the data frame duplicate the data when considering data storage?
So it brings all the data to the driver node. So it's going to read and write all the data again. It's not so technically. So yeah, just what Dan said. So it's technically not data storage. Yeah. Are there any other questions?
Sorry, I was on mute. Not so far in the chat.
Okay.
Can I
Go
call
ahead.
out just one thing?
Yep.
For simplicity of many of your examples here, if you scroll up one bit, you save your view as temp view. Obviously, you would normally need to put in like a schema name, because this is just going to the default schema then. But normally, as you would do it, you would just do where it says schema, instead of temp view, you would do your org's schema dot temp view within that spacing. That was it.
Thank you, Dan. Okay, so we're going to kind of shift from talking about all the data frames to kind of really focusing on Spark R here. We're going to start out by talking about importing data into the Spark R data frames, and then we'll move on to exporting. And then, as you can see on the table of contents, we got a lot of things to get through today. So the way you'll go ahead and import data into, or pull data from the CDR into a Spark data frame is you'll go ahead and use the SQL function, specify your SQL within the quotations there, and that'll bring in the data into a Spark R data frame. So for these, we bring these three tables in: the house, price, train, the house prices test, and then the house price sample submission. And we're going to use these three data frames throughout the presentation here. So if you want to go ahead later and practice, you'll have to go ahead and run this cell and bring the data in. And a little bit about the data is it's Ames housing data. There's almost 80 variables, and kind of the primary reason why it's in Kaggle is it's part of a challenge to predict the final price of each house. Kind of moving on, another way to get data into a Spark R data frame is by importing a CSV file from S3, and you can go ahead and call the read.df function, specify the S3 path there. You'll go ahead and specify CSV for the source option. You can include that header equals true, which is going to include the headers. You can also include the option infer schema, and that's going to kind of infer the different variable types there. You can also use the read.df for other various file types like JSON, Parquet, text. One file type you can't use direct or import directly into a Spark R data frame is going to be that Excel. And the way you'll do, or the way you'll import an Excel file from S3 into a Spark data frame is you're going to go ahead and move that Excel file to the driver node and load the Excel file into an R data frame, and then you can convert it to a Spark R data frame if you want to. Looking at the code here, this little piece of code is going to install the OpenXLSX package if it hasn't been installed before. This is going to load the Spark R and the OpenXLSX package. This is getting the current directory of the Spark cluster. This is finding the S3 location, and you can find that using that S3 location macro in SAS. And then we go ahead and copy that file from the S3 to the local cluster there. And then we'll go ahead and load that Excel file into an R data frame and go ahead and convert it if we want to. Exporting data to the CDR from a Spark R data frame, we can simply use the save as tables function, specifying that data frame here, and then the database name there. And we can check. We can see if the table exists using the table exist function there. Similarly to what we did before with importing a CSV file we can also export a CSV file. This time, instead of using that read.df, we'll go ahead and use that read.df or write.df, sorry. We'll go ahead and specify the data frame there, the S3 path there, and then kind of the type. So we'll go ahead and specify CSV. Overwrite if we want to have the most current data, so it overwrites the previous times. And then we can also include our headers there. Writing the Spark R data frame to a CSV is going to write it out kind of to a folder, and that's going to be because of Spark's distributed nature. So all this code here I'm not going to go in detail one by one, but basically what it does is it grabs the file that's in that folder and kind of puts it in this location here, getting rid of that folder that was created by Spark's distributed nature there. If there are more than one CSV file within that folder, I would try to go ahead and reduce the number of partitions. So you only end up with one CSV file in that folder. And you can go ahead and use that coalesce option to reduce the partitions to one there. You can also export an Excel file to S3 from Spark R data frame. Like I said before, Spark R does not natively support importing and exporting Excel files. So we're kind of doing the opposite of what we just did. We're going to go ahead and convert that Spark data frame to an R data frame and then create that Excel file, and then go ahead and copy the Excel file to the S3 location. Moving on to common transformations for Spark R. So kind of a transformations are operations that modify the data, such as filtering, select, or creating columns. As a reminder, the computation is deferred until an action is called due to Spark's lazy execution. So some examples of actions that are going to that are going to trigger that execution plan are examples are like data retrieval, which would be like collect or count, displaying data like display or show DF or print, saving or writing data, such as save as table or write, calculating statistics such as describe or summary, or converting data frames such as dot data frame. So that's just kind of a reminder, and you can kind of see through my different examples here. I usually do a transformation, and then I'll call an action, so I can show you guys the output here. Kind of moving off of that reminder and into the common transformations portion here. We're going to look at column operations. And the first column operation we're going to look at is selecting columns. And kind of one thing to note is selecting only the needed columns will improve your performance. And how you'll do that is you'll use the select function, specifying that data frame, and then you can kind of specify the columns kind of in three names. You can use the quotations here. You can use the data frame, the $sign, and then the column name, or you can go ahead and specify a column, and then you can go ahead and specify the column name within there. I personally like this one. It's kind of the simplest of the three. And then we go ahead and display the data here, kind of reiterating the point above. This is going to be the transformation, and then this is going to be the action. And we'll see that kind of throughout here. Another column operation is going to be creating columns, and you'll use the with column function. And this example here is going to create this large area living variable. based on this condition here, which indicates it has a large lot of over 10,000 square feet, and then a large living area. And it's going to create that variable with values of yes if it specifies, no if it doesn't. And I use that select that we learned before and go ahead and display those 3 columns. And we can go ahead and go in and look to make sure our logic is correct after creating that column there. Another thing you can do is rename columns. And this one's pretty simple. You just go ahead and use the with column renamed function. Specify that data frame. This is going to be your old variable. This is going to be your new, or this is going to be your old name. This is going to be your new name. So your build is getting renamed to year of construction, and then we can go ahead and check to make sure we named it properly using an if else kind of QA statement here. So if the year of construction is in the column names of this data frame, then we can go ahead and print that it does exist. Else the column year of construction doesn't exist, meaning we didn't rename it properly. So in this case, we renamed it properly and the year of construction exists. You can go ahead and another thing you can do is drop columns using that drop function, and then go ahead and specifying that column name there. You also can drop columns using the select function, and then kind of using that negative in front of the column name there. So these two statements are equivalent. You can go ahead and kind of use the same QA check that we used above here to make sure that the miscellaneous is no longer in that data frame. So if it is, we'll print that it exists. If it's not, we'll say that it doesn't exist. Well, we dropped it, so it's not going to exist here. Moving on to data selection. You can find a subset of a data set, a subsetting of a data frame using the limit function, and kind of getting that sample data is going to be good for testing and writing your code. So this is going to use the limit function. You're going to specify that data frame, and then you can specify how many rows you want there. So this is going to limit the data frame to 10 rows. Another data selection thing you could do is filtering the data frame, and you can use that filter function, specify that data frame here, and then whatever whatever operation you want to specify here. For this example, it filters for properties under that 300,000 mark. And then, so say we are looking for properties under 300,000. We're just kind of starting out. Maybe we want to look at certain variables and certain stuff to, kind of start out our search. So I use that select option and kind of grab some relevant stuff like overall quality, lot area, year bill, full bathrooms, that kind of stuff, neighborhood. So you can kind of, take the relevant columns from your search there. Another common transformation you can do is kind of organizing your data. So we're looking at sorting here. So sorting can be very resource intensive. Or just a note on sorting. Sorting can be resource intensive due to moving / kind of shuffling data between nodes. So that's just something to put in the back of your mind before kind of doing unnecessary sorting and that kind of thing. The way you go about sorting is you'll use the arrange function, and then you'll go ahead and specify that column name there. It does default to the ascending order, but if you do want to use the descend option, you can as well, and you just kind of pair that on the outside with the column name there. Another thing you can do is grouping and aggregating. So this example uses kind of the average function and then group by. And what this is going to do is it's going to find the average sale price for each neighborhood here. So say we don't want to have it non-dollar formatted in our display. Maybe we're presenting it somewhere or other. You could go ahead and add the dollar formatting. This is kind of more for kind of display purposes, as it'll create it as a string, but it'll add the dollar sign out front, and then it'll format the average sale price that was created up here with the 2 decimal places. Combining data, so you can go ahead, you can join 2 data frames using the join function. You can specify the one you want. So say if it's a left join, if you want this to be on the left side, you'll specify that first here. And then this one's going to be the data frame you'll be joining with. You'll go ahead and specify the variables that you'll join on there. And then you'll specify how you want to join. Left, right, inner. And then you can add this little QA check. I like to kind of see what columns are added after I join. So that's basically, or that is what this is doing here. We're getting the columns of the original data frame, the join data frame, and seeing the difference of the two there, and then go ahead and printing out the added columns there. And so you'll see the new fields added after the join is sale price. You can also append 2 data frames. So we're making a null value for the test data frame, as sale price is not included with that test data frame. So we're creating a null value for that column for that data frame, and then we'll go ahead and union those 2 data frames by the column name. And we can kind of look at the row counts to make sure it all makes sense and kind of keep track of kind of the size of the different data frames and kind of is it kind of what we expected. So these lines of code are finding the different counts from the Spark R data frames, the first one, the second one, and then the combined one. And then we can also print those row counts. And this is kind of similar to like a formatted string in Python. That's exactly what it is. It's going to be showing this row count of Spark R trained df, and then you'll be able to call this count underscore Spark R train df that you created up here. You can go ahead and call that down here. We specified that this portion right here, the percentage.d, as it is expecting a number, and then this will go right here, and I'll show you that just below here, and then this is going to specify that end of row, the new line character there. And if you don't specify that new line character there, it's just going to write all on one line there. So as you can kind of see from the output here, it's the row count of the first data frame, the row count of the second data frame, and then it'll give that total there. Okay, moving on to dealing with data issues. We create an example data here with some duplicate observations. Let's see. It's going to have duplicate ID value 5 and duplicate ID values of 8. And we can find how many kind of duplicate values there by counting them for that ID variable there, and then we can go ahead and filter those out, and that's what's going on here. To actually dedupe on the ID value, you can use that drop dedupe or that drop duplicates function. So after we get rid of that, or after we do that drop duplicates function there, we can do a dupe check after the dupe, and we can see there are no duplicates there. You can also replace values. So say you have in aims in the neighborhood column, you can simply use the with column function paired with kind of the if else here. So if the neighborhood is equal to in aims, make it north aims, else, use the regular value. And we can go ahead and make sure that we replace those values correctly, selecting the distinct neighborhood values here. We can go ahead. So here's North Ames, so we correctly replace the value there. Another thing you may do when you're dealing with data issues, maybe you need to find missing values. So we kind of create some more sample data. We're going to kind of get the calculate the number of total rows here. Kind of what these two things do are kind of cool. So this first portion here is going to find the kind of the null percentage for each column. And the way we do that is we use this sapply function, which is going to apply this function that we built here which counts all the null values. It's going to apply that to each column. So this finds all the null values and counts them. Like I said before, it'll find it'll put the null counts here, and then end up using that total number of rows over and finding that that null percentage there. So for example, looking at the ID column here, we have 20% nulls. Name would be or age has name 20%, age would have 40% as well. And this last piece here, it's going to display the data frames with rows where each column has null values. And that's kind of cool, especially if you're looking for, an example. You need an example of, say, when the ID is missing. That's not what you're expecting. So you go ahead and run that, and that'll give you example, or that'll give you the rows where the ID is null, or the name is null, or the age is null. You can go ahead. Another thing you can do is fill missing values, create more sample data here, and then we'll go. This time it has missing data. We can go ahead and use the fill in a function, and then we can go ahead and specify what we want those missing values to be changed to. So you see the initial data frame here with the nulls, and then the filled data frame with those filled values here. Let's see. How much time do I have left? Like 10 minutes?
You have about probably like 7-ish minutes,
Okay.
so we can get to the survey at the end.
Okay, let's try to. Okay. Lastly, in the dealing with data issues here, you can go ahead and drop missing values. Two ways. You can either drop any, or you can drop rows with any missing values using that drop in a function. Or you can also use the drop in a function and kind of specify which rows you want to, or specify which rows you want to drop for different columns here if they have a null value. So we see the initial data frame with those null values. After we use that drop in a, which drops all the rows that have missing values, we don't have any data left. But if we specify, say we only want to drop rows for columns, or drop rows with missing values in the age column and score, we end up with that one row, and it still has missing data in that name column. But that kind of shows how to use those different the drop in a function there. Moving to working with dates, I'm gonna have to quickly move through the rest of the stuff here. To work with different dates in Spark R, you can use the with column function. So say you want to extract the year, you can just tag it on the outside of the date there. You can also do something similar with the month and extract the month from the the date. You can extract you can extract the day of the week, and then this EE option is going, or this EE format is going to show the full name of that date. Another thing you can do, you can also difference dates, and this shows an example of differencing the current date with, say, date of birth. And then we can go ahead and calculate the age from the number of days since date of birth, dividing that days by or that difference by the 365.25 to incorporate the leap year, and then using that floor function there. You can also filter on the date, specifying that as dot date there, and then specifying that year, month, and day. Lastly, we can do kind of a quick hitter section, looking at some quick QA checks. You can display the schema using the print schema, and that will show you the column names, the data types, if it's nullable. You can display the internal structure, similar, or we already saw this one before. It's going to display the data frame type, kind of the column names, the data type, the sample data. You can inspect the first 5 rows. You just use that head function, specify the 5 rows, and then use that display function, and it's kind of useful for a quick look at the data, kind of ensuring that it's what you want. You can find the row counts, specifying, using that count there, and you can kind of put it all in one statement if you want to, or you can kind of break it up into 2 like we did before. But this is just concatenating this text with the output of this, and then that'll end up showing up like that. You can make a single variable table using that summarize function. And then this is going to count the houses for the neighborhood count, and then you're just grouping that count for that, or into that neighborhood. You also I like to see kind of the highest numbers first, kind of the most frequent. So I added this portion here to kind of take the descending order and look at kind of the neighborhoods with the most houses in the data set. You also can create a cross-tab table, looking at kind of the combinations of values from 2 variables. So this is looking at kind of the combination of the neighborhood and then the overall quality. So say you want to live in a good neighborhood, you could look at these 9s or 10s. This looks like a pretty good neighborhood, this 4th one down here, North Ridge. So maybe you want to check that one. Maybe you want to check that neighborhood out more in your housing search. But that's kind of an example of how you would use that to get that cross-tab table there. You also can get summary stats, count, mean, standard deviation, min, 25%, 50%, lots of summary stats there. So that kind of wraps up the QA portion here. And then I wanted to take just one moment here and kind of go over this Spark Dataframes Using R cheat sheet that I teased earlier. So it's going to have pretty much all the operations I covered within the notebook here, importing, exporting data, selecting columns or column operations, data selection, organizing data, combining data, dealing with data issues, working with dates for both Spark and then Sparkly R as well. And then lastly, I included some additional resources. This is going to be the path for the 5 topics for the office hours. This is going to be kind of the notebook for the R, R for SAS programmers. Another demo Dan did for R. Or wait, I think that one's Kyle's. This data catalog with R is Dan's. All very good notebooks with a lot of good content in them. And some documentation, some things you can read. This is my favorite Spark kind of source. Here's a Spark R blog, 10 things I wish someone had told me before I started using, I'll fix that later. I started using Apache Spark, a Spark overview, Sparkly overview, and then plenty more examples, sparkbyexample.com there. So that concludes the comprehensive working with data frames using R. Doesn't look, do we have any time for questions or should we answer them?
I think at this point, all questions have been covered in the chat by the team, but we do have only a minute left and we want to get to our survey just to make sure we get people's feedback on how we did and how we can improve.
Yep, sounds great.
Okay, awesome. Thank you so much, Colton, and thank you to our participants.